Alright guys, today we're going to be doing our division test review, and so this is with 3 and 4 digits, and then also we will be interpreting remainders. So on your test tomorrow you will be able to complete each problem either using sticks or stones or the standard algorithm. I'm going to try to switch it up just for the students who decide to do sticks and stones versus the students who decide to do standard algorithm. So let's look at number 1. We have 4,500 divided by 9. So I'm going to set this up 9 into 4,500. And I'll do sticks and stones first. So we're going to break apart our division problem. Can 9 go into 4? No, it can't. But I have 4 stones left over. But I can't do that, so we're going to have to regroup. Well, this is 4 tens, so 40 plus 5 gives you 45. So now I can count by 9. 9, 18, 27, 36, 45. So that made 1, 2, 3, 4, 5 groups here, and we had 0 groups here. Well, can 9 go into 0? No, it can't. So this will be 0. And can 9 go into 0? No, it cannot. So again, this is 0. There are no remainders. So our answer here is C. And remember to check your work, especially on the test. So remember to check your work. You're going to multiply your quotient times your divisor. So 500 times 9. 0 times 9 is 0. 0 times 9 is 0. And then 9 times 5 is 45. And then you need to make sure that your answers check out, which they do. Alright, number 2. 113 divided by 5. So 5 into 113. This time I'm going to do the standard algorithm. So 5 can't go into 1, so it goes in 0 times. 5 times 0 is 0, so then I'll subtract. 1 minus 0 is 1, and now I can bring down my other one. 5 can go into 11 2 times. 5 times 2 is 10. Subtract that. 11 minus 10 is 1. Bring down your 3. And then 5 can go into 13, again, 2 times. 5 times 2 is 10. Subtract that, and we get a remainder of 3. So our answer here is 22 remainder 3, which is D. Again, check your work. 22 times 5. 5 times 2 is 10. 5 times 2 is 10, plus 1 more is 11. Then we can't forget to add this 3. So that makes 113. So as you can see, our answers do match up. Alright, number 3, sticks and stones again. Now I'm going to divide 3 into 1098. Split up your what you're dividing into, and then ask yourself, can 3 go into 1? No, it can't. So I have 1 left over, which means I need to regroup. The 0 is going to become a 10. So now I can count by 3s. 3, 6, 9. Remember, we can't go anymore because it would go over 10, so we have to add a stone. 9, 10. So we had 0 groups here, and 1, 2, 3 groups here, with 1 left over. Well, we can't have 1 left over right here, so we're going to circle it and regroup it. So this 9 now becomes a 19, and then again we will count by 3s. 3, 6, 9, 12, 15, 18. If I go any more, I'm going to go over. I'm only trying to get to 19. So 18 plus 1 more stone makes 19. Again, we cannot have a remainder in this column, so we'll circle it and regroup it. So now this 8 becomes an 18. So we'll count by 3s again. 3, 6, 9, 12, 15, 18. So we made 1, 2, 3, 4, 5, 6 groups here. And we made 1, 2, 3, 4, 5, 6 groups here. And we did not have any remaining. So our answer is 366, which is A. Again, we need to check our work. So 366 times 3. 6 times 3 is 18. 6 times 3 is 18, plus 1 more is 19. 3 times 3 is 9, plus 1 more is 10. 1098, 1098, so they check out. Alright, number 4. I'm going to divide 4 into 288. This time I'm going to do standard algorithm. So 4 into 288. We're going to split it up. Can 4 go into 2? No, it can't, so we're going to put a 0. 4 times 0 is 0. And then we're going to subtract. 2 minus 2 is 2 minus 0 is 2. And then bring down our 8. Now I need to ask myself, how many times can 4 go into 28? Well, I know that 4 times 7 is 28, so I'm going to write a 7. 4 times 7 is 28. I'm going to subtract. 28 minus 28 is 0, and then bring down my 8. Now I need to ask, how many times can 4 go into 8? Well, we know that 4 can go into 8 2 times, so then we're back to multiplying. 4 times 2 is 8. When you subtract that, we get 0. So we have a remainder of 0. So our answer is 72, which is C. But let's check our work to make sure. So 72 times 4. 2 times 4 is 8. 4 times 7 is 28. So we have 288, and we started with 288. So our answer checks out. Alright, number 5. We're going to do sticks and stones for this one. So 3 into 4,653. We're going to split it up. Alright, we're going to ask ourselves, can 3 go into 4? Yes, it can. So 3 and then 4. 1 stone is left over. We know that we can't have that, so we're going to regroup it. The 6 becomes a 16. Again, we're going to count by 3. 3, 6, 9, 12, 15, and 1 more will make 16. So again, we cannot have this 1 left over, so we'll circle it and regroup it. This 5 becomes a 15. 3, 6, 9, 12, 15. We don't have any left over. And then 3 can go into 3 exactly 1 time. So now let's put our groups. We have 1 group here. We have 1, 2, 3, 4, 5 here. We have 1, 2, 3, 4, 5 here. And we have 1 here. So our answer is 1,551, which is B. Again, we're going to check our work to double make sure. So 1,551 times 3. 1 times 3 is 3. 5 times 3 is 15. Again, 5 times 3 is 15, plus 1 more is 16. 3 times 1 is 3, plus 1 more is 4. So I got 4,653, which is the same thing that we started with, so our answer checks out. Alright, here's our first word problem. So I should suggest with your word problems to write out your big D, your little d, your Q, and your R, just so you make sure that you circle the correct answer. It says, Mr. Bradford rides his horse 5,621 minutes. 5,621 what? Minutes over a period of 7 what? Days. If he rides his horse the same amount of minutes each day, how many minutes did he ride his horse each day? Okay, so already I'm going to pull out my big D, my little d, my Q, and my R. Well, I know that my big D is my biggest number, so 5,621, but we gotta put labels. 621 what? Minutes. Then our little d is 7. 7 what? Days. Remember, you can find your quotient in the question. Qua goes with qua. How many minutes did he ride? So we're looking for minutes. So this will be something minutes. And then remember, your remainder always matches your big D. And your big D was minutes, so your remainder is going to be minutes. Alright, now we're ready to divide. So we're going to divide 7 into 5,621. I'll do standard algorithm this time since we did sticks and stones last time. So 7 cannot go into 5. 1, 2, 3, 4, 5. So we have to move these stones over. Now these are 5 10s. So that means this 6 is not going to become a 16, but it's going to become 10, 20, 30, 40, 56. Now we can, oh, I'm sorry, I am doing sticks and stones, that's cool. Now I am going to count by 7. So we have 7, 14, 21, 28, 35, 42, 49, and then